No, bro.
All right, which ones do you want to go over?
What?
Number one,
Wait, what was the answer?
4,000.
Oh, yeah, here you go over that.
Yup. He just asked a question about this class, so please pay attention to the answer. Otherwise it will. Number one. So we're here on page 283. Number one, when the Huns debouched from the Alpine passes, Attila found that 18% of the spear points were dull. If 720 spear points were dull, how many spears did the Huns bring with them? So remember that for these percentage problems, you're always going to end up setting up something like this. Some number is some percent of some other number. Yes?
Yeah.
Okay, now, if they give you a percent, you might be able to fit it in there. What are they asking about here? What information are we going to be looking for?
How many spears did the Huns bring with them?
Okay, so what is that? That's the,
Actual number.
or we might say the total, right, the total number. The other information they give us is about what kind of spears, not the total, but
How many were dull?
how many are dull. The dull spears are a subset of all the spears. Here's where, if you want to draw a diagram, you could. Here are your spears. Spears. And then some of them are dull. Yes?
Mm-hmm.
They tell us what? What do they tell us about the relationship between the dull spears and all the spears?
18% of the spear points were dull.
Okay, so 18% of what is dull?
The spear point.
So which one of these is that?
The total.
The total one. 18% of the total is what? Is what?
How many is 720?
Is 720 is the dull ones. The dull ones, and how many dull ones are there? We said dull is 18% of, we could say, the total. Dull, well, we know that there are 720 dull ones, is 18% of the total. Yes?
Yeah.
The diagram can be helpful for these because we know that the dull has to be a smaller number than the total. This is 720 in here. This is going to have to be a much larger number. This is only 18% of the total.
Yeah.
Yes?
Yeah.
Okay. Once you get it set up like this, solving it shouldn't be much of a problem.
Divide.
Let's run through it quickly. What are we going to do?
720 equals 9 over 50 times C.
720 equals what?
9 over 50 times C.
Yeah, 9/50ths of t. Now what do I do?
720 over 1 divided by 9 over 50.
Yeah, or better would be times what?
50 over 9.
Times 50 over 9.
Then divide 9 with 720.
Yeah, 9 goes into 720 how many times?
Wait,
80. 80 times. 9 goes into 720 80 times. 80 times 50.
It is 400.
4,000.
Be careful. 8 times 5 is 40.
Oh, yeah.
And then we have 2 extra zeros there. So we get 4,000.
That's 8 times.
We got 4,000 total. So there's 4,000 in all. And 18% of them, or 720 of them, are dull. When you get to these, go back and mentally plug in the number that you got to the original scenario. They have 4,000 spear points total. 18% of them are dull. That's 720 spear points. Does 720 sound like it could be 18% of 4,000? Yeah, that sounds pretty plausible to me. It's a lot less than half. It's more like a quarter. Or less than a quarter. Somewhere between 10% and a quarter. So somewhere between 40 and 100. That makes sense. But yeah, you're always going to be setting up something like this. Some quantity is some percentage of something else. Next, you want to go over from the homework? Yeah, we'll do. You asked about 20. Okay, so we'll do 21, and then we'll do 20 because 20 is a good one to review, and it's from one of the lessons we covered yesterday. So let's do 21. Yep,
Was it 11 radical 5 minus 30 radical 2?
that sounds right to me.
Can I use the bathroom? now?
Yes. Hurry up. 21. 7 radical 20. Minus 5 radical 32. Minus radical 45. Minus 5 radical 8. Is that right? 7 radical 20, 5 radical 32, 4. Yeah, okay. What do I have to do here? What comes first in my order of operations?
7, 20.
What comes first in my order of operations?
10,
Okay, after parentheses comes what?
20.
So what am I going to do first here?
And find square root.
I have to deal with these square roots first. Remember, the square roots count as exponents for the purposes of my order of operations.
Yeah.
So, 7 radical 20, what's another way to write that?
7 times 10 radical 10 times radical 2.
Okay. It's not the best way to break down, but we can do that. Okay, how else can we write that?
7 times 2. 7 times 2.
Where'd you get 2 from?
2. Oh, no.
Radical 2 is not 2.
2 and 5.
Where's the 5? What are you talking
You're
about?
breaking down 10.
Oh, you want to break down 10. 7 times what?
2.
No.
Radical 5.
What? What are we breaking down radical 10 into?
5 and 2.
No. We're breaking radical 10 down into radical 5.
That's what I said the first
No,
time.
it's not.
I said radical 5.
You just said radical 5.
Oh.
You can't just say radical 5. Radical 10 does not give you radical 5. We can rewrite radical 10 as radical 5 times radical 2. And we still have the other radical 2 in there.
So
Now what do I do?
7 times 2.
Where'd you get 2 from?
Because square root of both 2's equals 2.
Right, square root of 2 times square root of 2 gives us 2. So we've got 7 times 2 times radical 5, which is what?
14 radical 5.
14 radical 5. Okay, what's the smarter way to break down radical 20? Why?
I guess you can do it.
Why is that a better option? Because 4 is a? No.
Sorry, it's like you can.
It's a perfect square. So we should do radical 4 and radical 5. Radical 4 is 2. Radical 5. You should always try to get a perfect square out of there. You'll have fewer steps to deal with. It doesn't matter. I mean, we get the same thing. 7 times radical 20 would give us 14 radical 5 either way. Okay, what about our second term? 5 radical 32.
32 is 8 and 4.
Okay, we can do 8 and 4. What would be a little bit better than 8 and 4?
16 and 2.
16 and 2. Because 16 is a bigger perfect square. 5 times radical 16 times radical 2, which gives us what?
5 times radical 4 and radical 4.
5 times what?
Radical 4 and radical 4.
Okay, but what's radical 16?
4.
It's just 4.
Oh, right, yeah.
Yeah, 5 times 4 times radical 2, or the whole thing becomes
20 radical 2.
20 radical 2. Okay, third term, radical 45.
9 and 5.
What do we break down into? Radical 9 and radical 5. Which then, radical 9 becomes what?
3.
3. So we get 3 radical 5 for that one. Last term, 5 radical 8.
2 and 4.
Radical 2 and radical 4. 5 times radical 4 times radical 2. Radical 4 is what?
2.
Yeah.
So 5 times 2 times radical 2.
10 radical 2.
10 radical 2. Okay, now we've simplified each of these.
Yeah.
So now we need to combine them. 14 radical 5 minus 20 radical 2 minus 3 radical 5 minus 10 radical 2. Yes?
Yeah.
Okay, so which ones of these are like terms?
14 radical 5, 3 radical 5.
What do I get when I subtract 3 radical 5 from 14 radical 5? 11 radical 5. And what about 20 radical 2?
Minus 30 radical.
Yeah, now be careful because it's minus 20 radical 2,
And minus 10.
minus 10. So it's actually minus
30 radical.
30. Yes, minus 30 radical 2. That's how you get to that answer there.
That's a
Wait,
lot.
did I say something different?
I don't think so.
Oh, I thought.
You have to make sure that you're first simplifying each of these radical expressions correctly. Now, as time goes on, you should become familiar with some of these. 20, you should know is 2 radical 5. Radical 20 is 2 radical 5. You should know that radical 8, is 2 radical 2. These should start to become really familiar. You look at 45, you say it's 9 and 5, and so without even writing out all the steps, you should be able to say 3 radical 5. Because 45 we can break down to 9 and 5. Radical 5 we can't break down any further, so it's radical 5, and 9 becomes 3. So the more you do these, the less you'll have to write out all these steps. But you need to be familiar with the perfect squares, certainly at least up to 12. That'll really help you out. Be very, very familiar with those, and just work on being comfortable with breaking down non-prime numbers into factors, into different factors. Remember, there's usually a number of different ways we can break something down into factors, like 32. You have 32. Different factors we can do with that. We can do 1 times 32. We can do 2 times 16. We can do 4 times 8. And then backwards, for example. Okay.
Can I go to the bathroom?
No.
Okay.
Please go before class. You get here early enough to go before class.
Okay.
Thank you. Next, number 20. This is something we talked about yesterday. 20. It wasn't on the homework. That's fine. We'll do it together. A over B minus 4 over x over b minus b. What do we have to do here to simplify this rational expression?
A over b minus 4 times b over x minus b.
No, we cannot take the reciprocal. We can't just flip this. We're not allowed to do that. We're going to need to flip some things, but first we need to make there'll only be one fraction on top and one fraction on bottom. So how can we combine the two terms on the top into a single fraction, a single rational expression?
4 over 1, simplify b.
What?
You gotta get the common denominator.
What's the common denominator going to be?
b?
4b.
B. So what are we going to get on the top?
Minus 4b over b.
A minus
A over B
Minus.
minus 4b over b. Okay, which is going to become what?
A minus 4b over b.
A minus 4b over b. All right. On the bottom, what are we going to do?
Same thing.
Well, similar thing.
It's gonna be b squared
b
over b.
squared over b.
Yeah, x over b minus b squared over b, which becomes what?
X minus b squared over b.
X minus b squared over b. Now what do I do? Now that I've got a single fraction on top and a single fraction on bottom,
Keep change flip.
now I can do my keep change flip. Because remember, this just means division. So what we're doing is we're saying a minus 4b over b divided by x minus b squared over b. So we do a keep change flip. We get a minus 4b over b times,
b over x minus b squared.
right, now what do I do?
Well,
You do the
you
thing.
can do b parentheses a. Oh, cross out the
A,
b.
B.
Yeah, cancel out here.
Yeah.
And I get what?
A minus 4b over x minus b squared.
Yes, there you go.
Mr. O.
Yes.
Can we get our test back today?
Oh, yes.
Yes.
Yes. Yeah, we'll do that. We'll do that in just a minute. After the homework, before we go into 70.
Okay.
Can you just say the answer to 29?
29?
Yeah.
Sure.
Please.
Answer to 29 was 800 square inches.
Let's go on.
Other ones from the homework that you want to go over?
No problem.
Or just
Okay, let me get the tests back. The test average, I think, was a little bit better this time than last time, which I was pleased about. There were a couple of problems that I want to go over, including number one. I don't think anybody got correct, which was
We all involved.
it was a little
It has to
frustrating.
be a life hack somehow.
It wasn't a huge deal.
For what?
Most of you didn't lose a huge amount of credit on it, but nobody got the correct answer, except for me. There weren't any particularly high grades on this test, though. The average was not so bad, but there weren't any super high grades. All right, but there weren't any super low grades either, which was nice. There's a low standard deviation, which means in general, standard deviation has to do with how far away from average the numbers are. So your scores were all grouped together fairly closely. So number one, every single one of you got wrong. Let's do number one together. The ones I wanted to go over together were number. Well, let's start with number one. I'll find my copy where I marked which one's going to go over. Somebody read number one aloud for me.
The number of bacteria increased by 240% overnight. If there were 40,000 bacteria yesterday, how many bacteria were present this morning?
Okay, so we're talking about bacteria yesterday and today.
Yeah,
And how does the number change from yesterday to today?
it doesn't. No, it increased by 250%.
It increases from yesterday to today. By how much?
250%.
So if it increases by 240%, what percent of yesterday's bacteria do I have today?
A bigger percent.
A bigger percent. How much bigger?
140.
Yeah.
240% more. So what percent
Oh.
of yesterday's bacteria do I have? 340%. Because I still have all the bacteria from yesterday plus 240% more. So today's bacteria is what percent of yesterday's bacteria?
340.
340%.
Oh.
Because it increased by 240%. That's a 240% increase. That's on top of the 100% of yesterday's bacteria that existed yesterday. All yesterday's bacteria are still there, plus another 240%. That's what a 240% increase means. So today we actually have 340%. We have just over 3 times as many bacteria
Oh,
as we had yesterday.
30.
Most of you, that was the mistake you made. You used 240% instead of 340%.
Yeah, I did that.
Okay, now what do I do? At this point,
4,000 for T.
no.
Oh.
4,000 is, no, nothing about that's right. What's the number and where does it go? Anybody?
So
Anybody want to walk me through the rest of this?
there were, the total, so.
No, yesterday. So you're gonna put 40,000 at once.
We put 40,000 in for Y. 40,000 goes in for Y. 340 over 100 times, we can put it over 1. Yes?
Yeah.
Okay, now what do I do?
You could 17 over 5.
Okay, we can rewrite this as 17 over 5, yes. 340 over 10 is 17 over 5 times 40,000 over 1. What else can I do there?
You can
Make a 1 and 4.
What's 40,000 divided by 5?
it'll be 80.
Oh.
8,000, right? 40 divided by 5 is 8, so 40,000 divided by 5 is 8,000. Okay, so we end up with 17 times 8,000. What's 17 times 8? Well, it's 7 times 8 plus 10 times 8.
96. Wait,
56 times,
Oh.
56 plus 80.
136.
56 plus 80, 136,000. Yes. Obviously, you could have also done the math by hand. Just do 17 times 8. 56, 8 plus 1 is, 8 times 1 is 8, plus 5 is 13.
So T equals.
But don't bother doing this with 8,000. All right, you can easily just add those zeros back in. Just do 17 times 8.
So the final answer is 130.
Is 136,000. Now, is 136,000 is that over 3 times 40,000? Yes. 3 times 40,000 would be 120,000. That's over 3 times as many. That's more than a 200% increase. So that makes sense as an answer. But that was the thing, is that a 240% increase means that you end up with 340%. Yep.
I get 2 points off of this one, 2 or 5.
Probably you didn't list all the possibilities there. So 5A, what answer should you have for 5A? Anybody?
Integers, whole numbers, and
So 5A, we should have integers, we should have what else? Whole numbers, we should have what else? We should have natural numbers, we should have
Real.
real numbers, we should have what else? There's one more.
That's fire, dude.
Let's remember A, whole integers.
We said integers.
I don't know.
Rationals. It's also a rational number.
Not rational.
No, R is reals.
Uh,
So reals, you didn't have to write this one. If you left out reals, that's fine because it asks about subsets of real numbers. Technically, reals is a subset of real numbers. Any set is a subset of itself. This is a true statement.
Wait, what? Wait, can you say the answers again?
That's true, but
I don't really know the song.
so integers, wholes, naturals, rationals, reals and rationals. Here's the order that it's best to write them in. It would be naturals, wholes, integers, rationals, reals.
It wasn't B.
What?
It's just-
And what about B? B
Real
is,
numbers, irrational numbers.
yeah, real, and then if you wanted to write irrational, irrational is not really a subset. I mean, it's not really a thing, irrationals.
Let's put real numbers.
Yes. Yeah, you should have put real numbers there.
On B.
Or irrational, at least one of them.
For number 4, you said I got that one wrong, but I don't see what's wrong with it.
Yeah, put a rational.
I guess it says -3.
You put which ones for B?
I just.
Okay, if you have a question about how I graded that, show me after we finish going over it, and I'll take a look at it.
I think you marked mine wrong. I got
It's
it.
possible that I made a mistake. So if you have a question about how I graded yours in particular,
Did you know we're after?
Yeah, because like you said I got -3.
okay, so the ones, number 4 was the next one that a lot of you messed up on. So number 4, let's start by just setting it up correctly. Number 4, so read number 4 for me.
Alright. 8 2/5 of what number is 2 1/10?
Okay, how do I write that as an equation?
8 2/5 times WN
Yeah, or whatever variable you want to use.
equals 2 and 1/10.
Equals 2 and 1/10. Okay. What do I do now?
Turn them into improper fractions.
Yeah, I could do that, but let's not do that until we're sure that we have to do that. What am I going to do here? What am I trying to accomplish in this problem? What x is? What's getting in the way of my finding out what x is? That 8 2/5. How do I get rid of that 8 2/5?
Divided by both sides.
Divide what?
8 2/5.
Right, divide 8 2/5 out of both sides. So x equals 2 1/10 divided by 8 2/5. Yes? Yes?
Yeah.
Okay, how do I divide mixed numbers?
Well, first you gotta make it improper.
First I have to turn them into improper fractions. What's 2 1/10 is an improper fraction?
21 over 10.
21 over 10. What's 8 2/5 is an improper fraction?
42 over
42 over
5.
5.
Or
Now what do I do?
keep saying
Now I do a keep change flip. 21 over 10
times 5 over 42.
times 5 over 42. What do I get?
We can simplify.
Simplify what?
That'll make
5 and 10.
5
5 and 10 become what?
1.
Yeah, 1 and 2, and 21 and 42 also become 1 and 2.
Mhm.
And I end up with 1/4.
Alright.
Why is that? Wait. Why?
Why? Because that's what 2 and 1/10 divided by 8 and 2/5 is.
No, like 42 and 21.
Because 21 times 2 is 42.
Wow.
Or you can divide them both by 7. 21 divided by 7 is 3. 42 divided by 7 is 6. And 3 and 6 give us 1 and 2. This, dividing of mixed numbers is something we've been doing from the beginning of the year. Still see guys making errors on it. One mistake that you might have made is you might have seen two fractions with different denominators and changed them to have the same denominators. That shouldn't change your answer, but it's an unnecessary step where you might make a mistake.
What lesson is number 7?
Number 7, that was based on like 63 or something, 63 or 64.
Skip it.
Actually, it's based on 64. Okay, the next one I want to talk about from the test is, 7.
Yeah.
Yeah, 7. 7, they tell us x minus 3 is not greater than 0. And they also tell us what? What else do they tell us in number 7?
After following. Oh, d equals integer.
The domain is integers. Okay. What am I going to do first?
Can you put the 3 on the other side?
How?
Add 3 on both.
Okay, so we get x is not greater than 3. What's another way to write x is not greater than 3?
3.
X is less than or equal to 3. That was a mistake a lot of people made. A lot of you saw not greater than and you changed it to less than. Equals is also not greater than. X is less than or equal to 3. And don't forget the second part. Our domain is what? What is a domain? What is a domain? You need to know what a domain is. This is from lesson 64. Do it again.
Isn't it like dictate?
Right, is which answers are possible. Like if I'm talking about how many children I have, 3 is possible, 5 is possible, 17 is possible, unlikely but possible. 0 is possible, -1 is not possible. 4.5, not possible. Pi, not possible. If I'm talking about the number of children I have, my only options are my whole numbers. 7 radical 2 is not an option, yes. So here, our possible answers have been limited to what? Integers. So when you're graphing this, you need to make sure that you're not indicating anything as a solution that isn't an integer. By saying the domain is integers, we've eliminated everything that's not an integer. And only things that satisfy both of those conditions, both that it's less than or equal to 3 and that it's an integer, are going to count as solutions. So what's the largest solution to this inequality with this domain?
Well, 3.
Why does 3 work? Does 3 satisfy this?
Yes.
Yes. Is 3 an integer?
Yes.
Yes, it is. So 3 works. Does 4 work?
Yes.
Does 4 satisfy this?
Oh, I was looking at the one, but no.
No. 4 is an integer, but it doesn't satisfy that. So what else are solutions here?
2, 1, 0, -1, -2.
2 is a solution. 1, 0, -1, and so on, forever to the negative integers.
So there's no line.
There's no line. Because what the line means is everything on that line is a possible answer. The dot means only this point. We're only going to use the line if our domain is real numbers. Because remember, a line, what's the difference between a line and a point?
Mine goes for
What dimensions does a line have?
all of them.
No. How many dimensions does a line have?
1.
1, just length, or width, whatever you want to call it, length. How many dimensions does a point have?
2. 1.
0.
Oh.
A point has no length or width. It only indicates that single point. So when I put these dots here, that means 4 is an option, but nothing greater than 4, nothing between -4 and -3 is an option. -4 is an option. -3 is an option, but nothing in between is, because there are no integers between -4 and -3. If I put the line there, a line is made up of an infinite number of points. A line covers every point that's along there. And so by using a line, what I'm saying is everything between those numbers also works as a solution. But since I've limited myself to integers only, I shouldn't be writing that.
You put our directions on the other side.
Not yet.
Oh my god. I did.
The next one, where there were issues, there were 3 more. Where there were noticeable issues. Those were 17, 18, and 20. I don't want to do all 3 of those. 20 really,
Yeah.
20 I don't want to go over. 20 is just a matter of using the 2 formulas. Which 2 formulas do you need for 20?
A triangle and a rectangle.
No.
Oh.
I mean, you could do that, but no. Which 2 formulas do I want you to use for 20? First of all, what are they asking for in 20?
Surface area.
So surface area is what?
2 times area to base plus perimeter to base times that.
Yes.
I don't know that.
What's the other formula that you're going to need to use for 20?
For 20.
Yep. What shape is that base? What kind of quadrilateral is that base in number 20?
Prism.
What kind of shape is the base, though?
Trapezoid.
It's a trapezoid. We need to find the area of the base, so we need to find the area of a trapezoid. What's the area of a trapezoid?
Base 1 plus base 2 times the height divided by 2.
Base 1 plus base 2 in parentheses times height, all divided by 2. Yes. Most of you did not use both of those formulas.
I split it.
A lot of you used at least one, at least the first one. I think most of you guys used, but the trapezoid one also. Yes, you could have treated it as a rectangle and a triangle. You can do that. It will work out to the same thing. But if you use the formula for a trapezoid, you're giving yourself fewer opportunities to make mistakes, and thereby decreasing the chances that you make a mistake. The fewer steps you can use, the more elegant a way you can work through the problem, the better. That's really what elegant means. It's not fancy. Elegant means straightforward, not unnecessarily complicated. That's what we should be aiming for in our math, because it's easier to understand and we'll make fewer mistakes. We're less likely to confuse other people, but we're also less likely to confuse ourselves. Okay, 17 and 18. I don't want to talk about both of these very much. 17 I'm not going to go through. You just got to be careful about your exponents there and doing the exponents on exponents. And when you have an exponent of 0, it's just going to turn to 1, so just ignore it. 18, how did they want you to solve 18? They told you to use what method?
Substitution.
Substitution. obviously you can always use elimination, or you can generally use elimination also. It just might be more complicated. They say substitution. The problem is set up for it to be easier to use substitution. How are you going to rewrite one of these equations to do substitution on?
You do y equals 2x minus 7.
Right, because notice it's 2x minus y equals 7. So we need to move the y to the other side to make it positive y. And then we get 2x equals 7 plus y. And then we subtract 7 from the right side. So 2x minus 7 equals y. It's very easy to get that backwards, to think that what y is 7 minus 2x. But that's getting it backwards. It's 2x minus 7. You could have also subtracted 2x, and you would have gotten negative y equals 7 minus 2x, and then you multiply both sides by negative 1, and then you would have gotten still to y equals 2x minus 7. Other questions about the test quickly?
What were 3?
So the equation is y equals what?
Negative x plus 2.
Okay, how do we solve these?
Yeah.
How are we going to solve it? How am I going to graph it? What am I going to do to find out how to graph it?
I just put in something for x.
Put in some x values. What x values do we want to use?
1, 0, negative
1, 0, negative 1, my favorite. Okay, if x is 1, what's y going to be?
2.
No.
Wait, negative 3.
No.
Oh my gosh, it's 1.
Thank you. Why is it 1?
Alright,
Because it's a negative.
Negative x is 1, is negative 1 plus 2. Negative 1 plus 2 gives us 1. Okay, if x is 0, then y is
2.
2. If x is negative 1, then y is?
3.
Because negative 1 is
Positive.
positive 1. Positive 1 plus 2 gives us
3.
3. Once you get to that point, you should be able to graph it pretty easily. I'll give you a hint there also. We're going to learn about this later in the year. If there's a negative coefficient on x, then your graph is going to be sloping down from left to right. If there's a positive coefficient on x, your graph is going to be sloping up. So since there we have y is negative x plus 2, just by seeing negative x, we know that it's going to be sloping down from left to right. And we'll learn later a method using that kind of knowledge to graph linear equations where we don't have to plug in different values of x. You might have learned it before. It's called slope-intercept method. All right, we're going to pause there. Corrections. So there won't be any written homework tonight. Corrections will be due Thursday. You got a few minutes to work on those. Thank you very much.
There's no homework tonight?
Other than working on corrections, no.